so this chapter has 2 marks weightage as far as IPE examination is concerned. I'll just discuss all the bits one by one, so slowly as possible, so it will enable you to write the question and answer as well, isn't it? So first question in this chapter, so this communication system, it's సమాచార వ్యవస్థ సంసర్గ వ్యవస్థలు అనే ఈ చాప్టర్ లో ఉన్నటువంటి మొట్టమొదటి క్వశ్చన్ ఏంటంటే, వాట్ ఆర్ ద బేసిక్ బ్లాక్స్ ఆఫ్ కమ్యూనికేషన్ సిస్టమ్? బేసిక్ బ్లాక్స్ ఆఫ్ కమ్యూనికేషన్ సంసర్గ వ్యవస్థలో ఉన్నటువంటి బిల్డింగ్ బ్లాక్స్ అంటే బేసిక్ కాంపోనెంట్స్. As I already told you, write down the question slowly. What are the basic blocks of communication system? So number 1, as I already told you, it is transmitter. Number 1, it is transmitter, then transmission channel, and after that receiver. So signal has to be transmitted, should be transmitted, and it should be received. So transmitter, transmission channel, and then receiver. These are 3 basic building blocks of any communication system, right? ఈ సంసర్గ వ్యవస్థలో సో మనం సమాచారాన్ని ప్రసారం చేసే వ్యవస్థ ఉండాలి, చేరవేసే వ్యవస్థ, పంపించే వ్యవస్థ, ప్రసారం చేసే వ్యవస్థ, అలాగే గ్రాహకం అంటే గ్రహించే వ్యవస్థ ఉండాలన్నమాట. ఈ 3 బేసిక్ బిల్డింగ్ బ్లాక్స్. So I'll repeat, what are the basic blocks of communication system? So you may note down. So first question, what are the basic building blocks of communication system? Transmitter, I will write as slowly as possible. Transmitter, signal has to be transmitted with the help of transmitter. Then channel, transmission channel, right? We have different channels are there, even Doordarshan channels, we have so many channels are there, allocated a separate bandwidth, the frequency range, it is called bandwidth. So that particular channel has to telecast the programs within that frequency only. So this TROI will be there, they will allocate the bandwidth. Next, transmission, second one, transmission channel. Transmission channel, right? So transmission channel, it can be through cable, through internet, or through sky or through space, so it can some channel will be there, transmission channel. Next, it is last one, receiver. I'll repeat. So the 3 basic building blocks of any communication system are transmitter, transmission channel, and receiver. Hope you have written that. Next, what is World Wide Web? What is World Wide Web? We call it www. So the websites, the address, so almost most of the websites they start that way, www, right? So what is this World Wide Web? All the computer systems, they're connected to the network. So one system will be connected to another system through this World Wide Web, right? It is an huge encyclopedia. You consider like an encyclopedia, this so entire knowledge is available in that book. This encyclopedia is like huge encyclopedia. Okay, so that is accessible to all the people across the globe, in fact, right? So at any time, round the clock, 24 hours. So that is the World Wide Web. It is a huge encyclopedia of knowledge, information. So that is accessible to all the persons across the globe. So round the clock. That is the World Wide Web. I repeat, World Wide Web. It is an encyclopedia. Write down www, World Wide Web. It is an encyclopedia, huge encyclopedia of knowledge or information that is accessible to all persons across the globe. So round the clock. That is World Wide Web. Next, third question, define modulation. Why is it necessary? Define modulation. Define modulation. What is its importance? What is its significance? As already told you, so modulation, the process of combining, mixing, so low frequency signal with the high frequency carrier wave to transmit it to large distances. That process of combining low frequency signal with high frequency carrier wave called modulation. సో మోడ్యులేషన్ అంటే మనకు సో సమాచార వ్యవస్థలో మనం చేరవేయాల్సినటువంటి ఆ సమాచారం సో తక్కువ శక్తి కలిగి ఉంటుంది అనమాట. సో దానికి తక్కువ పౌనపున్యం కూడా ఉంటుంది. దాన్ని ఎక్కువ దూరం ప్రయాణించాలంటే క్యారియర్ వేవ్, సో దాన్ని చేరవేసేటటువంటి క్యారియర్ వేవ్ తో రెండు ఒకదానితో ఒక మిక్స్ చేసేసి దాన్ని లార్జ్ డిస్టెన్సెస్ మాడ్యులేటెడ్ సిగ్నల్ సో వందల మైళ్ళ దూరాన్ని చేరవేయచ్చు అనమాట. దట్ ఈస్ మాడ్యులేషన్ ఇంపార్టెంట్. So modulation means the process of combining, mixing up of low frequency signal with high frequency carrier wave to transmit over large distances. So in order to transmit over large distances is called modulation. The technique, the method, the process, so involving the mixing up of low frequency signal with high frequency carrier wave to in order to transmit over large distances is called modulation. So note down the process of combining. For IPE examination is one of the important questions. Please make a note of it. Modulation definition: the process of combining low frequency signal with high frequency carrier wave to transmit over large distance, long distance. Okay, that's called modulation. Why is it necessary? దీని యొక్క ప్రాముఖ్యత ఏంది? మాడ్యులేషన్ ఎందుకు అవసరం? What is the requirement? As I already told you, in order to transmit the signal over large distances, one of the important applications, in order to transmit over long distances. Second one, to minimize or to avoid distortion, noise disturbance, isn't it? So last one, to reduce the size of an antenna. So this modulation is required. Next, mention basic methods of modulation. I'll write basic methods. Basic methods of modulation. Basic method of modulation. So as already told you, we discussed it here. So here, basic methods of modulation are the three modulation methods are there. AM, amplitude modulation. FM, frequency modulation. Then third one, phase, PHAS, phase modulation. This is amplitude modulation. Amplitude modulation. Please note down, dear students. Here, frequency modulation. Frequency modulation. So here, the characteristic, one of the characteristics of the carrier signal gets altered, changes in accordance with the signal to be transmitted. So a modulating signal, we can put it that way. So that is called, so accordingly we call amplitude modulation if amplitude of the carrier wave changes in accordance with the signal to be transmitted. That's amplitude modulation. Here the frequency of carrier wave gets modified in accordance with the signal to be transmitted. The last case, the phase of the carrier wave gets modified, altered, changed in accordance with the signal to be transmitted. So finally, mention the basic methods of modulation. Just mention for IPE examination for 2 marks: amplitude modulation, frequency modulation, phase modulation. Frequency modulation, right? Okay, coming to next part. Next, which type of communication is employed in mobile phones? The question of very interest. So nowadays, so cellular phones, the order of the day. Imagine life without cellular phones. Almost everybody is possessing cellular. Even the students nowadays forced to have smartphones in order to attend online classes or virtual classes. Okay, anyway, so which type of communication is employed? Just now I explained here sky waves, then space waves. This for cellular phones here 800 to 900. That frequency, high frequency signals goes the skywave transmission, line of sight. Okay, the basic mode of transmission employed in mobile phones is skywave propagation. As I already told you, the signal, the frequency is more than 30 megahertz. It penetrates through the ionosphere and then enters the space. And this signal, it is reflected back by satellite. It can reach the surface of the earth, right? Same system employed, same method is employed here. That is, space wave communication is employed in cellular phones or mobile phones. So, through line of sight, LOS, line of sight, line of sight, LOS. Space wave communication through line, LINE, line of sight, is employed in mobile phones. Please make a note of it. Which type of communication is employed in mobile phones? Space wave communication. Space wave communication. Antarjala. So, Telugulo space wave not Antarjala. Space wave Antarjala Tarangalu. Okay. ఉపయోగిస్తారు అన్నమాట మొబైల్ ఫోన్స్ లో. నెక్స్ట్, what is the skywave propagation? Just now we discussed. Please note down what is sky wave propagation. Sky wave propagation. What does it mean? So just now we discussed here the signal transmitted in the form with the help of antenna. It gets reflected back. So it by the reflector. Reflect means your ionospheric layer, the high density ionospheric layer acts like a reflector. It gets reflected back to the surface of the earth. So the radio waves get reflected back to the surface of the earth by ionospheric layer. They are called sky waves. Sky waves are nothing but the waves so received on reflection from ionospheric layer. It's called sky wave, right? Sky wave propagation is employed. So because here in nature, this earth is enveloped, surrounded by the atmospheric layer consisting gas molecules. These gas molecules get ionized due to the radiation that we received continuously from sun, mainly ultraviolet radiation. So at certain height, so what happens? This density of ions is more, concentration is more. That acts as a reflector. The waves get reflected. The waves having more than 30 megahertz get reflected back to the surface of Earth. They are called sky waves. The waves that received on reflection or after reflection from ionospheric layer are called sky waves. So just make a note of it. The waves that received after reflection from ionospheric layer are called sky waves. Next, mention various parts of ionosphere. Here, different parts of ionosphere. So just now I removed the diagram. So this surface of the earth is surrounded. We have different layers like this type of layers. So here, so from the surface of the earth, so up to from F1, F2 different layers, you can call it like this, at a height of 65 kilometers to 75 kilometers. D layer, ionospheric layer is called D layer, right? Here the density of gas molecules is more, so it's close to surface of that. Next, this one, so the F1, F2, so this 90, roughly 90 kilometers. Then here 190 kilometers, 100 kilometers, E layer, different layers. So from surface of the earth, the atmospheric layers are classified into different layers: D layer, E layer, F1 layer, and F2 layer like this. Here this F2 layer, so 170 to 190 kilometers. And here it will be 252, so roughly 400 kilometers range. The different layers. So in somewhere in the middle, we have the reflector. the density of ionized particle is maximum, it acts like reflector to these waves. So 4 layers. Mention various parts of ionosphere. Various parts of ionosphere are D layer, E layer, F1 layer, F2 layer, like this. So this here F1, F2 layers, this during night time and daytime, the range may fluctuate, change. The merge at night time. F1, F2 may merge. And then mention frequency range of speech signals. Frequency range of speech signals. Speech signals generally over cables, telephones and all those things, when you communicate with other person, the frequency range is 300 Hz to 3100. So just please make note down, make a note of it. So mention frequency range of speech signals. The frequency range of speech signals is 300 Hz to 3100 Hz. So this is about communication system, and then the possible questions in your IPE examination. Next, we'll take up one more topic. So that is only exclusively as per the latest chapter-wise weightage. So those chapters have 2 marks questions and weightage-wise. Those questions we'll discuss. So one by one, some chapters. Ray optics, the second chapter. So after your mechanical waves and sounds. So now you just analyze the chapter-wise weightage. Whichever chapters have more weightage, so such chapters you concentrate more, focus more, or emphasize more. But if you are aiming to score 10% mark, 60 out of 60, so this very short answer question, 2 marks question, play key role, an important role. If anybody is intending to score 60 out of 60, you don't have choice. Whereas in section B, so earlier you have 6 out of 8 questions. Now the choice is increased. You have to answer 6 out of 12 questions. You have to answer 6 out of 12 questions in section B, 4 marks questions, short answer questions. So now last section, section C. Earlier 2 out of 3 questions. Now the choice is increased. 2 out of 4 questions. 2 out of 4 questions, 8 marks questions. Section B, so 6 out of 12. You have plenty of choice in section B and C. So you can take little bit of liberty. But those who are intending to write competitive exams, you better prepare without leaving any topic. Be thorough with all the topics so that you can compete with the quality students across India. So now section A plays very, very crucial role. If anybody is intending to 10% or 100% mark, 60 out of 10 sciences. Why? Because you need to answer 10 out of 10 questions. You don't have any choice here. That plays a very, very crucial role to score 10% marks. Now we'll take up one more chapter, the ray optics, the second chapter. Just within 5 minutes, just recollect the topics we discussed in ray optics. So to begin with, refraction. Refraction, don't get confused. Reflection, refraction, and then we discussed all the spherical mirrors, lenses. Now they have deleted 30% syllabus, spherical surfaces. But what is the refraction? So the ray, whenever ray travels from one medium to another medium, at the separation of two media, that is interface. Suppose one medium M1, this is another medium. The separation of two media, interface, it is called interface. Separation of two media XY, this interface. Then the ray, when it travels from one medium to another medium, it bends and travels. So this is normal. This incident ray, this is refracted ray. So this angle of incidence measured from the normal angle of incidence, this is angle of refraction. Isn't it? The bending of light, simply you can put it in a simpler manner, the bending of light at the separation of two media, at the interface, called refraction, isn't it? Now specifically if you want to discuss total internal reflection, critical angle. The ray must travel from denser medium to, it is a mandatory, rarer medium. The ray must travel from denser medium to rarer medium. As you gradually increase the angle of incidence, so increase gradually this angle of incidence, then the ray bends more, the angle of refraction increases, value increases. So as you go on increase the angle of incidence in denser medium, the ray gauges moves along the interface. That angle of incidence in denser medium, at which the ray moves along the interface, or the angle of refraction or becomes exactly 90 degrees, that is called critical angle. The angle of incidence in denser medium for which the angle of refraction becomes exactly 90 degrees is called critical angle, isn't it? Suppose this angle of incidence more than critical angle, this I is more than critical angle, the ray reflects back into same medium as denser medium, isn't it? Well, total leads to total internal reflection. Whenever ray travels from denser medium to rarer medium such that the angle of incidence is more than critical angle, then the ray reflects back into the same medium, that's a denser medium. Phenomenon is called total internal reflection, right? You might have studied in optics. So these applications also, you might have optical fibers transmit the signals using this phenomenon. So this is formation of mirage, also total involves total internal reflection. Similarly, the rainbow, so formation of first order, second order rainbow. One of the phenomenon is this one, this TIR, total internal reflection. Okay, so after that, what is Snell's law? What is refractive index, a prism, dispersion, and all those things you might have studied, just to recollect all the topics. So to put it in a nutshell, so in a brief manner. So refraction, total internal reflection are very, very important as far as IPE examination is concerned. Okay, then Snell's law, and then refractive index, dispersion, the splitting of composite light, white light, into its constituent colors, 𝗧𝗦𝗔𝗧 colors. The phenomenon of splitting white light into its constituent colors called dispersion. Suppose a white ray travels through a prism. So what happens here? It will split up into its colors, constituent colors, 𝗧𝗦𝗔𝗧 colors, right? This white light, composite light or white light. Similarly, cluster group of water molecules also, they behave like a prism, and this split off the composite light into its constituent colors. Okay, let us get back. So the topics, very short answer questions. We'll take up one more topic or chapter, ray optics. Is make a note of it. Ray optics. One by one, we'll discuss very short answer question. So now in ray optics, as you know, the rays will travel in rectilinear path, straight line path. So lenses, mirrors, and all those things. If you have lens, so you have curved surface, transparent curved surface. It is a convex lens. It is a concave, like this. So when a rays travel, so along this optical center, and then we have principal foci, focus on either side. So passing through the principal focus, optical center, this is called principal axis. The rays incident parallel, the parallel rays, this is the rays coming from the distant object, converge at a particular point. This is called principal focus. In the distance between the optical center and principal focus is focal length. Then the radius of curvature, nothing but, so this is the spherical surface. It's the part of your spherical ball, right? Then the radius of the spherical ball from which the spherical surface is cut. So that is the radius of curvature. So radius of curvature is 2f, or f is equal to r divided by 2. Imagine a spherical, transparent spherical ball, slice it. So you just cut and make a spherical surface. Then the radius of the sphere, from which the curved surface is cut. That is radius of curvature. So for competitive exams, for IPE exam, relation between numerical problems or radius of curvature is 2f double, or f is equal to r by 2. Now, what is the focal length and radius of curvature of the concave lens? Case of lens, what is the focal length? As already the distance between the principal focus and then optical center. So if it is a mirror, we call it a pole of the mirror. Optical center, distance between the principal focus and then optical center is called focal length. Then the radius of curvature, please make a note of it. So define focal length, radius of curvature of concave lens. అంటే పుటాకార కటకం యొక్క నాభ్యంతరము వక్రతా వ్యాసార్థాన్ని నిర్వచించండి. సో ఇక్కడ ప్రధాన నాభి, ప్రధాన అక్షం మీద ఉన్నటువంటి ఈ సమాంతర కాంతిపుంజము ఒకానొక బిందువు వద్ద కేంద్రీకరింపబడుతుంది. దాన్ని ప్రధాన నాభి అంటారు. ఈ ప్రధాన నాభి అలాగే ఆప్టికల్ సెంటర్ ఈ మధ్య ఉండేటువంటి దూరాన్ని మనం నాభ్యంతరం అని అంటాం. ఎఫ్ అంటాం అనమాట. అంటే వక్రతా వ్యాసార్థం అంటే ఒక స్పెరికల్ బాల్ తీసుకొని దాంట్లో భాగమే ఈ వక్రత తలం కాబట్టి దాని యొక్క వ్యాసార్థం. ఓకే, దాని వ్యాసార్థం. రేడియస్ of spherical ball, the radius of the spherical ball from which the curved surface is the part of it or cut, that is called the radius of curvature. The relation between them, if anybody wants, here radius of curvature is double 2f, or f is equal to r divided by 2. Next, please make a note of it. I'll go as slowly as possible. What do you understand by the terms focus and principal focus? Principal focus, focus and principal focus. Suppose you have a lens, as I already told you, the lens will have two principal focus either side. So rays coming from left end will converge at a particular point right side on the principal axis. So all the rays they get converged at a particular point. Similarly, the rays coming from the other end, they converge at a particular point on the other side. So we have two focus. Foci, plural of focus is foci, isn't it? So the distance between principal focus and then optical center called the focal length. So now coming to this particular question, what is focus? Focus in general, so the rays coming from the distant object converge at it can be any point at which the rays coming from the distant object converge. That is called focus. So even if you focus it to heavenly bodies, so astronomical bodies, all the rays they get converged at a particular point. It's called focus, right? So any point, so at which the rays coming from the distant object converge, that is called focus. Whereas the principal focus means here it is a particular point on the principal axis. Be careful, principal focus is a particular point on the principal axis at which the incident rays, stream of rays, parallel rays parallel to the principal axis converge, or called principal axis, principal focus, isn't it? So focus means this is any point at which all the rays coming from the distant object converge, that is called focus. Whereas the principal focus means it is at a particular point on the principal focus at which all the rays, parallel rays, incident rays parallel to the principal axis converge at that point. This is called principal focus, isn't it? I'll repeat, the focus means any point at which the rays coming from the distant object converge, that is called focus. Whereas the principal focus means, so it is a particular point on the principal axis where all the incident rays, parallel rays parallel to the principal axis converge. Right? That point is called principal focus. Then what is optical density? How is it different from mass density? You are quite familiar to mass density. You have been studying right from childhood. Density, mass per unit volume, isn't it? Ordinary density is mass per unit volume, mass by volume. Density is mass per unit. This is mass density, isn't it? So how about optical density? Optical density, so generally this word we come across in optics. where the ratio of speeds of light, speeds of light in different media or two media, that is called optical density, right? So this is measured by in terms of refractive index, velocity of light in vacuum, say velocity of light, the velocity in a medium. So it is measured in terms of refractive index. And optical density is nothing but the ratio of speeds, the ratio of speed of light in two media, two different media is called optical density. I repeat, so ordinary mass density you are familiar, mass per unit volume is called mass density, whereas optical density means the ratio of speeds of light in two media, two different media is called optical density.